When we talk about limits, it's actually a calculus topic. So when you guys get to calculus, the first week or so of calculus will be basically a pre-calc review, but then you'll get into starting limits. And so we'll do a basic look at a few ways of calculating the limit. So when you read the definition, there's some stuff in there. It talks about if a function, right, f of x, they talk about a function, becomes arbitrarily close to a unique number. So if I had everybody put something into the function and then we started seeing all of the answers, we're getting really close to a certain number, then we would call it the limit. And so this is read, the limit as x approaches c, that says x approaches c of some function will equal L, this limit. But it's all about as the outputs get close to something. So we're going to look at this one. You can make a table to help estimate it. So what happens if I put 2.9 and 3.1 into our function? So you could go to the calculator and have it help you make a table. So you can go to the y equals, I'll clear that out. It is 5x minus 3, right?
Yep.
So if I want to do this, I could go, say, get close to 3, but we're 2.9 and 3.1. So we're going to just have the table switch by that. And you can see 2.9 is an 11.5, right? And in the table, 3.1 right here is 12.5. So I just type the function in, then I can use the table, and we're getting closer. So can you get closer than 2.9 and 3.1? Yep, you can call it 2.99 and 3.01. So on my calculator, I can go second window, and I want to start at 3 or get close to 3 again, but I'm going to go 0.01. So then when I go back to second graph, go to the table, you can see 2.99 and 3.01. So this is 11.95, and the 3.01 is 12.05. Right? And we can get even closer, so let's do it one more time. And you go second, table set, get close to 3 by 0.001. And when I look at the table, there's your 2.99 and your 3.01. So notice I haven't even looked where the question mark is. We haven't done anything here. I'm just getting closer. So I'm asking, this is what I said at the beginning, I'm asking you guys to put in 2.9, somebody else says 2.99. What are the red numbers getting close to? As you move in, they're getting close to what? 12. That's your limit. What? The limit is 12. Now, if I actually plug the number 3 in, so let's go ahead and plug this number in. 5 times 3 minus 3 is what? 15 minus 3 is also 12. So I know there's a 12 there, but I didn't need to plug that number in to find the limit. It was all about what was happening as we kept picking numbers that were getting closer to 3, right? We're getting closer and closer to 3, and you're starting to see. So the red numbers told me the 12. So remember what we're talking about is when I say get close to 3, we're actually moving in this way. So we're moving in from numbers that are not close to 3. Then I did a 2.9 and a 3.1, then a 2.99, then a 3.01. So my inputs, right? My inputs are getting closer and closer to 3. I don't ever need to plug in 3. What are the outputs doing? So again, when you follow the outputs, yeah, I started at 11.5, but now it got really close to 12. I started at 12.5, and now my outputs. So that's what we're getting close to. So after doing that first problem, when you talk about what is it getting close to, a lot of students go, oh, let's just plug the number in. So they get the brilliant idea to just put the 0 in. So you have 0 on top, square root of 0 plus 1 minus 1, which ends up 0 over 0. What's 0 over 0?
0.
Not 0,
1.
it's undefined. So what's going to happen is if you type it into your calculator, you're going to get an error. The fact that you get an error at that spot tells you nothing. Right? The chapter we just got done doing was talking about maybe it was a vertical asymptote, maybe it's a hole in the graph. We got to figure this out. It doesn't tell me anything about the problem. All it does is tells us to do something different. So if we went ahead and filled this in, we can do it one time. It's x divided by parentheses square root of x plus 1, right? And then minus 1 out here. So that's the function we're looking at. We're supposed to get close to 0. Get close to 0. And the first time we'll just do a difference of 0.1. So on either side I have 1.94 and 2.05. So this was 1.94, right? Where is it? Oh, that's 0. Sorry. This one didn't start with 0.01. It started with 0.01. Oh, and I forgot to start. So you always put the number you approach as your starting value, so on either side of it, and then you switch to the, so this one actually turned out to be 1.995, and this one was 2.005. I'm guessing right now you can already tell what's happening as you get closer and closer to here. What's the limit gonna be? These numbers will be super close to 2. So I'm guessing this one's 1.995, and this one would be 1.9995. This one would be 2.005, 05, and this one would be 2.0005. 05.
It's 1.995.
That's what I said, 1.995. Isn't it? Am I doing it wrong?
You think you're right, Mr.
I
0.0001 is
just
2.
don't wanna do
Whatever. Yeah. I mean, you can see what the numbers are doing. You're going to get a bunch of 9s on one side, a bunch of 0s on the other, and it's leveling off or getting close to a number. However, when I plug in the 0, it didn't work. By the third or fourth lecture, and we start talking about other ways to find limits, some students are going to tell me the limit does not exist.
What's the point of it?
So, this doesn't tell me anything. What I call direct substitution, taking the number and plugging it in doesn't tell me. I want you to really get in a habit today of looking at what are these numbers telling you? Are they getting arbitrarily close to something? Yeah. Will it ever equal exactly 2? No. Not really. I mean, if the calculator would allow all the decimals, you would see it would never get there. Okay. So I'm going to sketch this graph, and we're going to find some limits graphically. So I'm supposed to graph 1 when x is not 5. So here's where x is 5. Here's an output of 1. So it's 1 everywhere but right there. And if x is 5, it actually is going to be a dot down here at -2. So then what we do is we generally go around the room and we vote what the answer is going to be. And your 3 choices are, you're going to tell me that there is no limit. You would tell me that the limit is going to be 1, or the limit is going to be -2. Okay? So if you're supposed to approach x is 5, you're coming in this way and you're coming in this way, what's going to happen? Well, some people will say the limit is -2 because when you plug in -2 into this piecewise function, you do get an output of 5. But the definition up above is talking about pick dots that are closer and closer to 5. Where would you pick? I would say like do a 4.9. When I put in 4.9, what do you get? 1. When you put in 5.1, what do you get? 1. Can you get closer than 4.9 and 5.1? Absolutely. What's 4.999? What's 5.001? Where are you going to be? Really, you're getting really close to that hole, right? So wouldn't all my dots be arbitrarily close to an output of 1?
Yeah, we put a limit as 1.
The limit ends up being 1.
What is it?
Why do you even have it?
So if I ask you to graph this one, you could put some numbers in. If I say when x is 5, I get 4 over the absolute value of 4, well that's a 1. So when I put 1 in, I actually get 0 over 0 undefined. So we're going to have an opening there and this horizontal line at 1. Anything bigger than 1 will be 1. But when you put negative numbers in there, like negative 10, you get negative 11 on top. What's the absolute value of negative 11? So I get negative 11 on top and a positive 11 on the bottom, and what do you get? Negative 1s, right? So that's down here. That's the graph.
What?
So what they're asking us to do is look at this limit as x approaches 1. Now, if you pick the 1.1 and the 1.01s and the 1.001s, you're going to have dots up here getting close to, right? And if I pick the 0.9 and the 0.99 and the 0.999s, my dots are going to line up down there. So if you put your fingers in the air, right, 1 is here and 1 is here. Are your fingertips coming to the exact same spot?
No.
1 is up at positive 1, 1 is down at an output of negative 1, and they're not coming together. So what's the limit as x approaches 1?
There isn't one. What?
Limit does not exist.
Why?
I didn't write it right. Limit does not exist. D-N-E, sorry.
Wait, why?
So you can't have multiple limits? No.
You can't have like plus or minus 1. That's not possible.
And it's because they're
No.
separate.
Okay.
No, not when x approaches 1, because when you approach 1, we have to consider from the left and from the right at the same time. I'm going to jump ahead. We could do what's the limit as x approaches 1, from the positive side only. Then you're up at the top, so that would be a 1. Or you could do the limit as x approaches 1 from the negative side. Now you're down here, so the limit is negative 1.
What?
What's the limit as x approaches 5?
Was that 12?
What's the limit as x approaches 5?
1.
Because here's 5. And if I approach here and I approach there, where are we at?
1.
1.
So it's whatever line you want, whatever y line you are on, like, or
Alright, so example 3, do that quickly. It's a DIY. Graph it, talk about it, write it down.
Fun.
horizontal, wherever that horizontal line.
So remember, this is negative 3 down here as an output. So if I pick the limit as x approaches 2, so you're going to pick things that are 1.9 and 2.1 and 1.99 and 2.01. You're going to keep picking things coming in this way and coming in this way, right? But where would the output dots be on your graph as I get closer to, this is 1 and this is 2, right? So as I get closer to 2, where are my dots? There'd be a dot here and one here and one here and one here. So what are we getting closer to? Where are my outputs at? My outputs are close to
-3.
-3.